Hello everyone, welcome to another edition of Orion's Blue Box. You know, I struggled a lot myself early on in college, my undergraduate career, and I met a lot of students since then who struggle with word problems. And I've seen that almost in every case, they don't have a good method. So I thought I would shoot a quick video detailing problem solving method or steps to solve a word problem. This can be used for physics, math, any subject basically. The method itself is the same. So today I'm just going to be solving two really simple physics problems. They're easy, probably easier than anything you'll ever get on a test, but I just want to demonstrate the method first of all. Okay, so step one, read the problem. You know, I'm a big fan of the game Magic the Gathering, and there's this web channel I watch, Tolarian Community College. Check it out if you haven't, and if you're a fan of Magic, it's a great channel. And the professor on there, see, there's this saying, reading the card explains the card. The same thing for word problems. Reading the problem explains the problem. I remember I was teaching math class once and I assigned a word problem that I put on the overhead, and I gave the students about 5 minutes to work on it, maybe not that long, maybe 3 minutes, and I started asking, is everybody getting this? And everybody was complaining, no, I don't understand, I don't know what to do. So I asked them, what does the second sentence say? And they didn't know. And I asked them, well, what does the first sentence say? They didn't know. Did you read the problem? No. Hello? Big migraine for your instructor. Reading the problem explains the problem. So step one, sit back, calmly read the problem. Okay, so problem number one. A 5-kilogram object is given a force of 20 newtons applied along the positive x-axis. What will be the acceleration? Step one. You may even want to read that a second time. Now, step two, draw a box. Always draw a box. You may feel a little silly doing this at first, but always do it. Why? Because then you can put all your information in the box. So we have a 5-kilogram object. That means mass equals 5 kilograms. Oh, it's given a force of 20 newtons applied along the x-axis. So force equals 20 newtons. What will be the acceleration? So we don't know the acceleration. So there you are. Now I have all my knowns and my unknowns. So step two, always draw a box. Label your knowns and your unknowns. Then you have a snapshot of the problem and what you're looking for. Step three, draw a picture. This may not be applicable in every case, but if there's something physical going on in the problem, this helps you to visualize it. Very important. Also, your instructor may give you partial credit if he sees a nice little picture drawn, especially if it's funny and makes him laugh. I even had an instructor tell me that once. If you have a picture, and especially if it's funny, he'll give you partial credit. But anyway, seriously though, you can just draw a little picture. There's a little box here, let's say, and its mass is 5 kilograms, and it's on the ground, and I don't draw very well. But anyway, it's given a force, let's say 20 newtons there. Something like that is perfect, just to give you an idea of, what you're looking for. Maybe you can even say acceleration equals question mark. I don't know. I'm not being real technical in these problems. These are just basic problems that I'm trying to give you an idea of the method you should use. Now, where were we? Oh yeah, step one, read the problem. We did that. Step two, draw a box. Step 3, draw a picture. Step 4, look at your formula sheet. You may have a formula sheet, especially if it's an exam, that your instructor may allow you to use. Now notice, I did not do this step 1. Very important, because I got caught doing this. And after my instructor pulled me aside and was like, I've noticed on exams, the first thing you do is start looking over your formula sheet, looking for an answer. That's not the way it should go. And I started noticing other students doing that too. And even when I was a TA, teaching assistant, as a grad student, I started noticing the undergraduates doing that. The first thing they do is they panic and they start looking at the formula sheet, trying to figure out, oh my God, what formula am I going to use? No. Do all of this first. Get a good snapshot of what you're looking for. Then look at the formula sheet. Look, oh, here's force. I have that. Here's mass. I have that. There's acceleration. I'm looking for that. Ah, bingo. That's the formula I want. F equals ma. This is also Newton's famous second law. I'm a big fan of the second law. Awesome physics principle. Now, we've done that, okay? Now all we have to do is solve the problem. We're almost there. So, have to do a little bit of algebra here because we're looking for A. So you have to do something called isolate the variable. Isolating the variable. Some students I've run into have heard of that before, some people haven't. What I mean by that is you have to do a little bit of algebra and solve for the variable you're looking for. So here we want the A by itself on the one side of the equal sign. So the m is being multiplied, and you always have to do the opposite operation. So we have to divide both sides by m. M's cancel, and there, the A is isolated. I'm going to kind of rewrite this as A equals F divided by M, force divided by mass. So that's what I mean if I ever say isolate the variable, or if you ever hear your instructor say that, you want to get the variable by itself. So just a little bit of basic algebra here. Now we can plug in numbers. So we know that the acceleration we're looking for equals the force, which is 20, divided by the mass, which is 5. And of course, I made this a very, very easy problem on purpose. So acceleration equals 4 meters per second squared, because our units come out right if we did that correctly. So that's the answer. Bingo. Circle that. Now, the method helps you get there. It doesn't absolutely guarantee that you will solve the problem or solve all problems with 100% accuracy, but it makes it so much easier to attack the problem and to figure out what you know and what you don't know. So you have to do this every time. So let's look at another slightly more complicated physics problem. And again, let's see the method in action. Okay, so what do we have here? A 12.5 kilogram mass travels with kinetic energy equal to 100 joules. What is its velocity? So we have a 12.5 kilogram mass traveling with kinetic energy equal to 100 joules. And the question asks, what is its velocity? Great, so step 1 out of the way, we've read the problem and we think we have a pretty decent understanding of what's going on in this problem. Step 2, draw a box. So we're good there, we've drawn our little box. And now we fill it up with whatever information we have from the problem. So we know our mass is going to equal 12.5 kilograms. Kinetic energy equals 100 joules, and velocity we don't know, so we just put a big question mark there. We will be solving for that term. And so, step 3, draw a picture. Just a little simple picture. We've got a mass, whatever it is, moving at certain kinetic energy, 100 joules, and we don't know its velocity yet. So that then brings us to step 4. Hopefully you remembered to now look over your formula sheet and you saw that, hey, we've got a formula here for kinetic energy, which also features mass and velocity. So that must be the perfect one to use then. So we take that formula, write it down, and now we realize that we need v, which is velocity, and it's kind of stuck with a couple other things over there, so we're going to have to get rid of them. In other words, isolate the variable, use some algebra to get that v alone by itself. So, to make it easy on yourself, the first thing you should do is divide both sides by 1/2 m to get that out of there. Now, there is a very special rule for dividing by fractions, and many students I've taught throughout the years some remember it, some don't. I'd say only about half of the students remember that. Anytime you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. In other words, dividing by 1/2 is the same thing as multiplying whatever that quantity is by 2/1. And this makes sense if you think how many halves are in 1. Say if you divided 1 by 1/2, you would get an answer of 2. On the other hand, if you multiplied 1 by 2/1, you're multiplying by 2, then you're dividing by 1, which is just whatever, anything divided by 1 is that thing, right? So your answer is 2, and you get the same answer either way. So what we have to do here is special. Instead of dividing by 1/2, we multiply ke over m, because the m stays where it is, by 2/1. So we end up with 2 times kinetic energy over mass equals v squared. Ah, but you didn't want v squared, did you? You wanted v. So remember from algebra, whenever there's an operation being performed on a variable and you want to get that variable by itself, you have to perform the opposite operation. In other words, if it was v plus something, you have to subtract that something. Here it's being squared, so what is the opposite of squared? Taking the square root. So we have to take the square root of both sides. And now finally we have done that. So we are ready to solve. The square root sign knocks that squared off, as I said. You have velocity equal to the square root of 2 times the kinetic energy divided by the mass. And I created this problem to be sort of simple so that it would work out easily. If you plug those numbers in, you'll get 2 times 100, which is 200 divided by 12.5. Ends up being 16, and the square root of 16 is 4. So 4 meters per second is your answer. If you use this method, in no time at all you'll be solving problems like Kakashi Sensei from Naruto, and if you know who that is, you know he's pretty much unstoppable. So remember, the method is not an absolute guarantee that you will get the correct answer, but it's a way of approaching every problem consistently that gives you a fighting chance to solve whatever word problem it is in chemistry, physics, math, whatever. I hope you enjoyed this video. I hope you at least got something out of it. Please leave a comment if you have a specific question or subject you'd like to see addressed, and I'll try to either answer it or make a video about it. And also please support me on Patreon if you can. I'm just trying to get set up here in the early going, so these videos may be a little bit primitive. I'm still learning how to do this. I'm very new, but hopefully we'll get better as time goes on. And remember, never be afraid to learn a little bit each day.